Hello, and today I'm going to prove one of the most important identities in mathematics. That is the square of sine of an angle theta plus the cosine of that squared is equal to 1. Now this is a very important identity not only in mathematics but also physics and other subjects. We literally use it to power houses, phones, and devices and whatnot. And when I first learned this in high school, I was only motivated to memorize it because we were just given it and we weren't really explained what it means or how it came to be. We only were motivated just to memorize it and not so much as to understand what it means. But because it is literally used in everything, I feel like it's important not only to memorize it but to understand it. That's why I'm going to prove it. Now how can we go about proving this? Well, it involves the Pythagorean theorem, and the Pythagorean theorem involves right triangle like this. Let's say we give it some angle theta and a right angle over here. And basically, the thing is with right triangles, we're gonna have our hypotenuse, which is this longest line over here, and let's just label it C. And then we're gonna have two legs, which are not the hypotenuse, and we're gonna label it, let's say, A and B. Now, the Pythagorean theorem states that if you take the squares of those legs, a squared plus b squared, and add them up together, you're gonna get the length of the hypotenuse squared. Now, that's all fine and dandy. This is literally the Pythagorean theorem, but we're trying to prove sine squared plus cosine squared equals to 1. In order to do that, we're going to have to involve some trigonometry. It's very basic trigonometry. It's literally the definition of sine of theta. Now, what's the definition of sine of angle theta? Well, angle theta is over here. And let's say we look at the opposite side. Let's say over here is A. It's going to be the ratio of that side. So let's say opposite, because it's the opposite from the angle theta. And it's going to be the ratio of that in relationship to the hypotenuse. So let's put right hypotenuse over here. In our little example over here, that would be A. So opposite side is A. And that would be divided by the hypotenuse, which is labeled already C. And then we're going to do the same about cosine. We're going to define what cosine of theta is. And that's basically, it's very similar. It's the ratio of the adjacent side in relationship to the hypotenuse. So if I could write over here, that would be the adjacent divided by the hypotenuse. And in our case, that would be B, because that's the adjacent, divided by C, because that's the hypotenuse. Now we're going to do something weird. This is going to make no sense, but let's say we just do it. If we square both sides of these equations, we have to do that because when you square one side, you have to square the other. We get something like this. And if you square the other equation, you get something like this. Now what we're going to do is we're going to add these equations up together. If this makes sense. So if you add these equations together, let's do this side of the equation first. We're going to get sine squared of theta plus cosine squared of theta. That's all fine and dandy. We're going to ignore this middle section of these equations, and we're only going to focus on over here. We're going to add these two over here too. So we could get a squared divided by c squared plus b squared divided by c squared. Now, the cool thing is about these two terms is that they both have the same denominator. They have what's called a common denominator. So basically, we could combine the numerators and put them over the same denominator. So a squared plus b squared divided by c squared. Now, how does this relate to the Pythagorean theorem? Because we're going to relate it, actually. What we're going to do to the Pythagorean theorem, we're going to divide both sides of this equation by c squared. Just because I can, literally. And what happens when you divide something of the same thing, divide by the same thing? You get 1. C squared divided by c squared is equal to 1. So we could easily see that a squared plus b squared divided by c squared is equal to 1. But look, these two terms are the same. A squared plus b squared divided by c squared. They're all the same. So if this is equal to 1, then therefore this is equal to 1. And if we zoom out a little bit, we could see actually that sine squared plus cosine squared of theta equals to 1. So let's just combine this down here, and we get our finey dandy little expression over here. Not expression, it's the equation. Square of theta is equal to 1. Happy, 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 happy. Anyways, I hope that you enjoyed this little proof. It's not the most complex proof out there. It actually is the most popular proof of why sine squared plus cosine squared is equal to 1. And it's fairly simple relative to those complex ones. And it's actually probably the best one to learn because it actually has this added bonus, of defining what sine of theta is and cosine of theta is, and bringing up the Pythagorean theorem, which also shows up in a whole ton of other things. It's a very useful proof for understanding a lot of things. I think it's one of the most important proofs I know very well. So yeah, I hope you have a nice day, and goodbye.